beginning and intermediate algebra students. So you may remember this or you may not. I'm going to show this example, and you may need to go back to the review if you need more examples. We'll see. So first of all, I noticed that the numerator has degree 3, the denominator has degree 2, and they are in descending order. They have to be in descending order. And the other thing that I noticed is that degree 3, degree 2, degree 1, degree 0. No missing terms. So if 1 degree is missing from this sequence, 3, 2, 1, 0, then I have to leave some space, empty space. But there is no need in this case. So we have 4x cubed minus 10x squared minus 11x and plus 1. No space is required. And these two are in descending order, these two terms. So now the question is exactly the same as if I'm dividing just simple fractions, arithmetic fractions. So x squared times what is 4x cubed? So that is clearly 4x, because I know that when I divide degree 3 by degree 1, I have to get a line. So now I go back and distribute to both terms. 4x times x squared is 4x cubed, but I always have to change the sign because I have to subtract. This will be negative 12x squared. I have to change its sign into 12x squared. These two go away, perform the operations I see, and bring down the next in line. Now I ask myself, this times what is this? And at the top, we do not lie. I'm kidding. You know what I mean. I have to write the sign that is required. I'm not changing signs. And now I distribute 2 to these two terms. 2 times x squared is 2x squared. I have to change the sign. 2 times negative 3x is negative 6x. I have to change the sign before I write. These two go away, and then I get a negative 5x, and then plus 1. I cannot continue. I cannot ask myself x squared times what is negative 5x. So this original division now has this as quotient and has this as remainder and this as a divisor. So how do I write it? I have to write the quotient, 4x plus 2, plus, this is required, or minus, negative 5x plus 1 is at the top, over the divisor. So as I explained here, the slant asymptote is when x approaches infinity, or negative infinity. Well, where does this go? What do you think? Where does this fraction go when x approaches plus or minus infinity?
Negative infinity.
The denominator is more powerful.
Oh.
Whenever the denominator is more powerful, what happens to the fraction?
So it's divided by infinity, so it's getting smaller.
Very good. So as x approaches infinity or negative infinity, whatever over huge will always approach 0. So this goes away. Therefore, this y equals 4x plus 2 is the slant asymptote, just the quotient. Why? Because this will always go to 0. So the function will approach, if this is 4x plus 2, will approach the slant asymptote either from below or maybe from above, and the same thing here. So it's guaranteed that this function will have the limit at positive infinity, because the leading coefficient is positive, and when x approaches negative infinity, the limit will be negative infinity. If we find a negative leading coefficient, then I know that as x approaches infinity, the function will approach negative infinity. As x approaches negative infinity, the function will approach positive infinity because it has to follow the slant asymptote. Okay, so well, let's choose a whole example. And then I'll come back to that example that I started with a hole in the graph so we can see it, how to graph it. And then I'd like to go back to 4.2 and 4.8. Yes. Any preference?
$70.
70 it is. Very good. So I'm going to put it in the correct order. So y equals negative 2x squared plus 5x plus 1 over x minus 2. And I will immediately do this. I hope you become allergic to a negative leading coefficient as I am. Okay, perfect. I want to see if this 2x squared minus 5x minus 1 has real solutions. It does, but what they are. Okay, so I'm just going to put it in the apps again. Will it allow me to change this? I don't know why. Okay, no, it doesn't. No, it doesn't. Okay, never mind. So yes, I want the polynomial. It has degree 2. Yes, it does. Okay, graph, I guess. Leading first coefficient is 2. Okay, that's fine. The next one is negative 5. Will it change it? Yes, it changes it. Okay, and the negative 1. Okay, and now I want to solve. Okay, so x is negative 0.2 and x equals 2.7. Okay, good. I needed those. Those are the x-intercepts, right? So now I can start my table. Okay. So negative infinity, infinity. Can anyone give us the domain of this function?
Negative infinity to 2.
Excellent, thank you. So obviously x equals 2 must be a VA. So I have to find this limit, this limit, this limit, and this limit. And I have to plug in 0. So when I plug in 0, what will I do with all my preps? So when I plug in 0, what do I get?
1/2.
Yes, careful.
Oh, sorry, I didn't see that.
That's okay. Yes, I covered it. My bad. Sorry. Okay, so now we want to find these limits, and we want to find these limits. So let's start with these two because that's much easier. So limit as x approaches 2 from the left from and limit as x approaches 2 from the right. Okay, so let's see. When I plug in 2, I have negative but with minus in front, right? So 8 minus 10, negative 2 minus 1 is negative 3 with minus in front. From the left, from the right, it doesn't matter. The top will always be positive. Now, can anyone give us the sign as x approaches of the denominator as x approaches 2 from the left? 2 from the left is 1.9. 1.9 minus 2 is negative. So this is negative infinity. What about the sign from the right of 2?
Positive.
Good. So this is negative infinity, and this is positive infinity. Now I need those limits. So limit as x approaches infinity will not make any difference. Oh, it will. It will make a difference. It will make a difference. I was thinking of as a slant asymptote, of course, it will make a difference. Good. Of negative 2x squared minus 5x minus 1 divided by x minus 2. When x approaches infinity, where does the numerator go? And when x approaches negative, when x approaches infinity, where does the denominator go?
When it approaches infinity, it goes to negative infinity.
So this is infinity over this. This sign is not important. I can take the sign out. It doesn't matter. So it's infinity over infinity. What do we do with infinity over infinity? I'm happy.
Finally,
L'Hopital's rule. Good.
differentiate. Yeah.
Yes, very good. So then we have 4x minus 5 and 1. Where does this go when x approaches infinity?
Infinity over 1, which would be infinity.
Yes?
Negative infinity, sir.
Excellent. Good. So then here I have negative infinity. Good. What about the process till here? Doesn't make any difference, but now as it approaches negative infinity from negative 4x minus 5, where does this go?
Infinity.
So when x approaches negative infinity, this becomes negative infinity, and there is a minus in front. Is that clear, everyone? Yes?
Yes.
Okay, perfect. So then we have here infinity. Done. Let's move on to the first derivative. Messy. It's a messy problem, right? So I'll keep it here. So f prime of x. Negative stays outside patiently, waiting. The top prime, 4x minus 5, times the denominator, minus 2x squared minus 5x minus 1, times the denominator prime. Luckily, that's 1. Here I have no choice. I normally say don't multiply, please don't multiply, but I can't say it now. I have to keep my mouth shut. So 4x squared minus 5x minus 8x plus 10 minus 2x squared plus 5x plus 1. Can we get rid of anything? Just anything, please? Two x squared minus 8x plus 11. Awful, awful. Okay, so I don't know what this is. In the calculator, I'm sharing, and I will put in, okay, I will put in 2, negative 8, and 11. Yes. Okay, 2 is there. Negative 8. Does it? Okay. And positive 11, yeah. Okay. Oh, great. I'm happy. So b squared minus 4ac. Oh, yeah. Awesome. I couldn't be happier. So this is always positive. This is always positive. So the function is always decreasing. Yeah, I love it. Good. I don't have to study anything. I don't have to, it's never zero. Never. Never. Zero. Excellent. Positive over positive with minus in front. So now, the moment of truth. If these two rows don't work well together, then I'll say, oops. Okay. From positive infinity to 0, yes, that's acceptable. From 0 to negative 1/2, yes, that's acceptable. From negative 1/2 to negative infinity, awesome. From positive infinity to 0, yes, yes. From 0 to negative infinity, yes, awesome. Great job. Okay, now, let's see, do I want to do this? I'm just trying to be funny. It's not a pleasant second derivative. That's all I was trying to say. Okay, negative outside. Okay, the top prime, 4x minus 8 times the denominator minus the top times the denominator prime, just 2 times x minus 1 minus 2, of course, because the denominator prime is 1. Okay, x minus 2 to the 4th power. Yes, please do not multiply. Please. Right, now I have to say it. Factor out x minus 2. And here I have a 4x minus 8 with an x minus 2 left. This is out, and now I'll distribute minus 4x squared plus 16x minus 22. Minus 4x squared plus 16x minus 22. Yes, x minus 2 to the 4th. Yes, one of them will go away. I'm still hoping for some more simplification. Okay, x times 4x. X times negative 8. Negative 8x again, plus 16 minus 4x squared plus 16x and minus 22. Awesome. Brilliant. They worked hard to come up with something like this. Awesome. Let me check my numbers just to make sure. So 4x squared minus 8x plus 16, correct, minus and plus, yes, 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 awesome, great, 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 excellent, wonderful. So this is never 0, however, it has two different signs because this can be rewritten as this, 2 and 1. And yes, this is always positive, but this one not always positive. Is negative to the left of 2 and positive to the right of 2. Negative to the left of 2, positive to the right of 2. Done. Wonderful. Good pick. Well, I'm not sure who it was. I think it was Brian. Brilliant. I couldn't have fixed.
Say that takes you a while. Imagine us.
I fully understand. I fully understand. So, the slant asymptote, you will have to determine it, and yes, I fully understand that. But the work, the homework has to be done, because that's the only way you learn. You have to redo the problems we do in class and then do the homework. Please. Okay, ready. First we have to start with, we don't have to start with anything. I have to find the slant asymptote. I can't do anything before I do that. So I have to divide this by this. So 2x squared minus 5x minus 1. And we divide by x minus 2. Okay. So x times y is 2x squared is 2x. 2x times x is 2x squared, but I have to change the sign. 2x times negative 4, it's negative 4x, but I have to change the sign. Minus x minus 1. X times what is negative x? Negative 1. Negative x, but positive x. Positive 2, negative 3. You know what I mean. I meant to write here negative 3. So, negative x, positive x. Positive 2, negative 2, and negative 3. So, the function will be rewritten f of x equals negative 2x squared minus 5x minus 1 over x minus 2 as negative quotient minus the remainder over the divisor. But yes, I have to distribute now the negative 1. So allow me